tell how many positions you have. So these are both 2-2 valves. Now, this is a 2-2 spring return push button. Where do you use 2-2 valves?
When you just need air out.
When you don't need to do anything but block here, when you don't need a return path. So air blow-offs, air motors, air grinders, and then a lot of times we'll use them for media valves, which is fluids. So you either want to let the fluid flow or stop the fluid from flowing. All right, this one is a 3-2 spring return. What does that mean? Electric, purely electric, not electrically air piloted. And then where do we use 3-2s? Two places. Spring return, you only need one path in and one path out. And then we also use them for vacuum. Put vacuum air in the vacuum tender, then we need to take the air back out to run it. Here's an example of a 2-2 on an air motor. And when you are running an air motor is using CFM versus PSI. So it's not a sealed unit, so the air just runs through it, goes to atmosphere. This is a case where you would want to run an oiler. You cannot permanently oil. We can permanently oil our actuators and valve stuff because they're sealed units. This is not a sealed unit, right? The air is running through it right back to atmosphere. So this is where we would put the oiler on this. All right, this is a 3-2, and again with a spring return actuator. Go through all these pictures. All right, this is a 5-2. Let's see if I'm going to find a better 5-2. I don't have a better 5-2. All right, this is a 5-2. Where do we use 5-2? With a double acting cylinder. What are these things right there? Variable restrictions. And when you put variable restrictions in place of the mufflers, you're actually using them to control. All of you got to see a problem that we had out there where the muffler was clogged, and the muffler was clogged. What did it cause? It slowed you down. Because what's the last thing the air does when it goes back to atmosphere? It goes through the muffler. So if the muffler's clogged, that's going to cause your problem. We have the metal type sills and we have the O-ring type sills. Major difference, metal is faster, can live longer if you give it good, clean, dry air, and it can be rebuilt. Whereas we're going to tell you our O-ring type are throwaway. All right, this is a centering type valve, and the specific one is a closed center. Is this a good application for a closed center?
No.
Why not? And that's the answer is correct.
The cylinder's in a vertical position.
This is a vertical condition. You would need like some secure checks out here or something else, or a locking cylinder if you were doing this application. Typically, again, we wouldn't want to use the air to hold something in position. Air leaks off. All air leaks eventually. All right, this is a pressure center. Where do we use a pressure center? We only use it for balancing it with a locking cylinder. It's only used in conjunction with a locking cylinder. Did I give you an exhausting center? Where do we use an exhausting center? When you want to be able to move the actuator without turning the air off the machine. So if you had a clamp and you wanted the operator to blow, or it could be something as simple as like a box erector where the two actuators fold down the tops of the box. And the box gets crunched. And they need to get it out. Well, they open the door and they can't move the actuators because it's a 5-2. So now you have to shut the air off the machine to do that. Well, if you had exhausted centers, you could move the arms out of the way, get the box out, reset the machine, and get it running again. So any place you can get into a jam, basically. All right, naming conventions, NFPA. This is mostly what I've been doing during the week. PVA, exhausted B, exhausted A, the A shift side and the B shift side. The ISO is 1, 2, 4, 3, and 5. The 12 side, the 14 side. We tend to put both this and NFPA on most of our valves. But if you don't remember this, where can you find it? The survival guide, or look it up on the computer that's in your pocket. All right, this is the valve that you guys are using. So this is our VQ. The equivalent SY of that with the same flow capacity is about half the size. Every time they come out with a new generation of valve, they have more CV and less size on them, which is what everybody wants. Now what's actually going on inside of that valve is this. There is a spool in there. This is your P port. This is your B port. Your A port, your exhaust of B, and your exhaust of A. Notice on this side we have a smaller piston than the piston on this side because this is an air spring return. off of the P port, we are tapping off the air, and we're putting the air on the back side over here. So when you are not putting air on the front piston, that will push it. That's what it returns. So that's called an air spring return. This is the override, and then this is your solenoid valve. A solenoid valve is actually a 3-port valve. So what you've actually got in there, in this case, are 2 valves. You are sharing a common P port. We're tapping off the P port, right, for both of these. So we're tapping off the P port and bringing that over here. And then this is electrically operated. It uses very little electrical. And then this is my pilot air. So this is my pilot valve. And then this is my actual valve. Over here, we have an air spring return. Sometimes you'll see it symbolized like that. It's an air spring return. And then this is going to go up to your actuator, B side, A side. So this is your P, your B, your A, your exhaust of B, exhaust of A. Got it? When we energize this, that creates a path. Let's say we get 70 psi, it goes up there, shifts the valve, causes the actuator to go out. When we de-energize it, this one will also have a spring return. It will return. That will take the air back to atmosphere and allow the air spring return to push it back in the other position. Got it? If you have a problem with the valve, it can be electrical, mechanical leaks, or intermittent. And typically what makes it, as soon as something's intermittent, what do you think it's going to be? Most people, when you have an intermittent problem, everybody thinks it's electrical. I had the one out there that was acting funny, right? And every once in a while, it would, you know, if you pressed it, it didn't always run. Is that not an intermittent problem? And that was not electrical, that was pneumatic. Your voltage needs to be within 10% of what the range is for these things to operate normally. We have different types of valves out there, and remember about the surge suppression. You can order these with surge suppression. If you get one that doesn't have surge suppression and you're driving with a solid state relay, you need to put a surge suppressor on there, or I guarantee it's going to cause you problems later. Remember, we had that whole conversation about that. This sounds kind of silly, but there are little pins in there that go into here. You got somebody putting a valve in and they're struggling with it and they're getting mad, and they do this, palm it. And then the leads just fold over. And guess what? When you don't have electrical connection, it doesn't work. Indicator light. Just because the indicator light turns on, it doesn't mean the valve is good. It means the LED is good, right? So again, just because you've got that on there does not mean you could have an insufficient power to it. You could have something wrong with the coil. You could have something wrong with the pilot. You could have something wrong with the valve. So don't assume just because you see the light that the valve is good at that point. Yeah, I'm not even going to get into this wire spread. If you see a coil that looks like that, you put 120 volts on a 24-volt coil. I can guarantee it. This, I leave this up here because it cracks me up. In most cases, you are not going to hear any click on those valves, especially if you're out on most plant floors I've ever been on. The visual indicator is your best indicator that you're getting the signal there. Again, not 100% signal, there's something working with it. Now, this is important. Your pilot air needs a minimum amount of air in order to shift. Remember what I told you? You can't do what? You can't bench test a valve electrically without something in the A and the B port, because the air will just go to atmosphere, and it says, why would I push the spool around? But there is a minimum requirement for pressures. So if you were using a valve, let's say that this was a gripper, and it's a little bitty gripper, and we're grabbing something really tender, and I only want 10 psi out there. 10 psi is not going to be enough pressure for the pilot. So what you do is this. You cut this line, and now you use what's called an external pilot. So that's an external pilot you would use on here. And then I could put 70 psi over here and 10 psi in here. So who was it? Ruben was pointing out there's 2 holes in the bottom of the valve there. He says, why aren't those ports? They are ports. There's a pilot exhaust and an external pilot. So those are the additional ports. Now to use that, what you have to do is you have to get a valve with an R on it, which is an external pilot valve, and then you put it on the manifold, then use the external pilot. So we're just not using them right now. That's why we don't do anything with them. So again, if you're gonna, so there's the two ports, that's your pilot exhaust. The pilot exhaust has to be open atmosphere. If you don't like the fact that that hole is open there, the only thing you should put on there is a what? A muffler. But don't cap it off because that's your pilot exhaust. That's your pilot exhaust. You cap that off, he's not gonna shift. Got it? And then over here, this is your external pilot. We only use that if you are trying to use a different air to shift the spool than your incoming pressure line. We have valves on manifolds. Valves on manifolds can have layers to them. So there's different things we can put in. We can put regulators in here. So again, I've got 80 PSI in the valve manifold, but I've got a gripper out there. And I actually did this on the FMS. I've got one of my vacuums, and I actually put a regulator in between the valve so that I can drop the pressure down from the overall pressure I'm putting on the system. So it allows you to put individual pressures on individual valves. And then you can have these, which are called isolation. These are kind of nice. What they do is that allows me to turn off the air to that valve, replace that valve without turning off the air to the entire process. So for most parts, for manufacturing process, I don't care, but I made Prozac. So I own the process at Eli Lilly that made Prozac. It was $500,000 a batch. Did not want to drop a batch, right? So it took 2 days to make it, and if all of a sudden something failed in the middle of that, I don't want to shut that down in the middle of the process. So you can go over to shut down that one valve, replace that one valve, and then put it back into service without shutting the entire thing down. It's probably not necessary in all places. This is an override. The overrides come in three different. There's just a push button override, there's a slide lock, and then there's a twist lock type override. So that override, what does it do when you press the override?
Overrides?
It bypasses all of your logic in your control. So it could be something as simple as this. In your control, it says, don't move A if B is extended. And if you hit the override, guess what? Now we're gonna tear up the machine. For me, I would never, like if I talk to somebody on the phone, I would never tell them to go hit the override. Because they do, they go hit the override and it damages the machines I've got a problem. Or it could be something like this. You're gonna hit an override on this one and you think you're moving this actuator. I'm sitting down there underneath here, it's dark on this manifold. What's it gonna take for me to press the wrong valve, the one next to it? Now I move the whole wrong actuator. Or I move an actuator and when it goes, it hits a switch. And then when it hits that switch, then it starts the other part of the machine up, and I didn't intend to have that happen. If you don't understand what's gonna happen when you hit an override, don't hit the override. Now, if it was me, I wouldn't even have these locking type in most plants, on most machines. I would typically use these in like process, like waste treatment plants and stuff. There are a lot of times in waste treatment plants which you actually wanna override a sluice gate or open a valve, something manually. So they will do that. But in a regular plant, the advantage with this is I don't have to have anybody help me. So let's say that my controls are here and the machine's on the other side of that wall. So I can flip the switch over there, walk around the wall, and then when I get there, I found out that Chloe was over there standing in the machine and I hit her with an actuator. Now I'm gonna have to run. It's gonna be a problem here, right? I like this one because basically if I cannot see what I'm moving, I need to be on the radio with somebody. I need somebody's eyes on what I'm getting ready to do. Says stop, you're moving the wrong one. I need somebody looking at this. All right, I'm gonna give you a really bad case of using an override. So I worked at Cummins and I put in engine test sets for them. And the engines that we were putting the test cells in were called hedgehogs. It was from that wall to me, and it was as tall as this room. These were $1 million engines. You know why they called them hedgehogs? Because hedgehogs eat caterpillars. So we were making these big hedgehog engines. We had the engine splined to the dyno, running the engine at 100%, splined to the dyno, right? And I don't know what the guy thought he was doing, but he hit the override and told the hydraulics, and this was hydraulics versus pneumatics, and told it to undock. It separated the motor from the dyno. Now you've got this great big motor with nothing but a bunch of energy in it and nothing to use the energy. It walked itself around the room and did $250,000 worth of damage. That doesn't include the damage to the $1 million engine. I never saw the guy again. I don't know if they killed him, fired him, or both, right? Now, the nice thing is when you are building an engine test stand, it's built inside of a bunker, because eventually, when you're testing things, you expect them to do what? Fail. So nobody was hurt, but it was a significant amount of damage and a big setback to that test cell. So again, do not hit an override unless you understand exactly the implications. Now, in your class, if you hit the override, what's gonna happen? You're gonna move the actuator. Now, let me tell you one more thing about remember I told you you can't bench test a valve? You can't use the electrical to shift the valve, but you can hit the override with the opens and it'll shift the valve. So you can use that to test at least the pneumatic portion of the valve. So something to just be aware of. If you hit both solenoids at the same time, whoever hit it first is gonna win. So that's the direction you'll go. Springs break. Right, so over time springs are gonna weaken, and that could actually start causing you to get like intermittent problems. If the spring starts getting weak, right, sometimes you've got enough to shift it, sometimes you don't. All right, again, the metal ones, they do leak, and they will get scratches if you let any dirt get in the metal on metal. O-ring type, we're gonna tell you to throw away, and I'm gonna tell you, keep some in a box, because if you get to the point where you can't get a valve and your machine's not running, you can't get one for a week, I would take it apart, clean it up, put it back together, and try to make a valve work. Somehow or another, I'm getting my process to work. What I would never do is call that a fix, right? That's a temporary Band-Aid, get the valve on order. All right, I go through all that. Oh, there's a leak. So if you have a leak like this, you have a problem. Leaks are hard to find. So pretty much to find a leak, you need a tool. You guys know what tools you use to find leaks? One of them is called Snoop. Do not use the blue stuff you get from Ace Hardware. It will bump everything up. That is for gas lines. Snoop is a fluid that will bubble to show you the leak, but it evaporates and it doesn't gunk everything up. So Snoop is a specific brand of that. Don't use soap liquid. That again gets in and starts gunking everything up. The other thing you would do is get an ultrasonic sensor, and you can get a cheap one for $200 and you get more expensive ones. But basically what you're doing is you're looking for sound, and you either use headsets or you have an LED display, and it'll narrow down to where the actual leak is coming from. Tomorrow, when we do the manifold troubleshooting, I'll get some Snoop out and kind of show you, what you have to do to actually find that leak. Finding a leak is not a simple thing. Okay, so we're at the point that we're going to be ready to do the next lab. So next lab, I'm going to give you I can give you any problem. So any problem out there, and I'll give you a very descriptive, description of like acting funny or broke or not working or leaking or smoke. Got it? Let's do this. Go to lunch, come back at 12:30. If you don't want to take the tour, come back at 1:30. While you guys are at lunch, I will break everything so we won't have to take a break to do that. Everything will be broken. So after we come back from the tour, I think what I'll probably do, after we come back from the tour, I will go ahead and just go through root cause analysis. It's just a short little discussion on root cause analysis. It takes about half an hour. Then we'll go out and do our troubleshooting, so that when you're done with your troubleshooting, you get to go. So if you're except for you guys, they're all grinding and then you're stuck with each other. You just harass each other until you finish. Is that working for everybody?
Sounds about right.
Again, guys, at 12:30, I'm leaving. So if you're not back at 12:30, I'm assuming you didn't want to go on the tour. So if you want to go on the tour, I need you back at 12:30. If you don't want to go on the tour, just meet us back here at 1:30.
I didn't know you guys were related.
What's that?
You're his son.
Just that, I heard.
You're his son.
It's